In this video, we will be discussing about various encryption techniques, their mechanisms as well as applications. Generally, they can be categorized into symmetric and asymmetric. Now firstly, let's take a look on the symmetric encryption. Symmetric encryption means that the same key is used for both encrypting and decrypting. Let's take a look at an example to see how this works in practice. Bob wants to send Alice a message. Bob will generate a key and use it to encrypt the message. The message is then transferred to Alice together with the key. After that, Alice will use the same key to decrypt the message received. So what are some characteristics of symmetric encryption? The secret key can be either a specific password, code, a number, a letter, or a random string. There is also the concept of key exchange, and thus the security strength highly depends on this. Common variations of symmetric encryption are stream cipher and block cipher. In a stream cipher, each plain text digit is encrypted one at a time. A block cipher encrypts a block of text, rather than encrypting one bit at a time as in stream ciphers. Popular symmetric encryptions that are commonly used nowadays are AES 128, AES 192, and AES 256. Now, we will move on to asymmetric encryption. Asymmetric encryption is also known as public key cryptography. Instead of having one key as in symmetric encryption, there are public and private keys. Let's look again at Bob and Alice from earlier. In this case, Alice will generate both public and private keys. Alice then gives the public key to Bob and he uses that to encrypt the message. The message is then transferred to Alice. After that, Alice will use the private key that she generated earlier to decrypt the message received. Some of the popular asymmetric encryptions are RSA, El-Gamal and Palier. But what do they have that allow the public-private key scheme possible? Firstly, it is very difficult to factorize very large numbers. And this is even harder for semi-primes, which are product of two large, similarly sized prime numbers. And lastly, the existence of an efficient solution for this problem is not even provable yet. It's impossible to infer the private key from the public key, at least for current computation methods. We have talked about two encryption techniques, now let's explore their differences. Firstly, symmetric encryption employs a shared key for both sender and receiver. While in asymmetric encryption, public and private keys are used. Secondly, in symmetric encryption, the key needs to be kept secret between the two sides of communication. In contrast, the public key in asymmetric encryption can be shared to anyone. Last but not least, symmetric encryptions are generally fast and can be used for large files. On the other hand, asymmetric techniques are based on very complex mathematical problem and thus are generally slower. Now we move on to a slightly different technique called hashing. Don't confuse it with the popular breakfast dish. Suppose, we have a text message. Hashing will transform that text into a fixed string of random characters. Now we have the same text. But only the last character is changed. We can observe that just a small change of the input creates a massive change in the resulted hash. This is also known as the avalanche effect. So how is hashing different from other encryption techniques? In symmetric and asymmetric encryption, no matter which method is employed, the cipher text has the same size as the plain text. Small plain text yields small cipher text while large plain text yields large cipher text, accordingly. This is in stark contrast with hashing. Hashing algorithm will always convert the plain text into fixed-sized hashes. So we cannot infer the original plain text size. However, that is not the only difference. Encryption is supposed to be a two-way process. That means the cipher text can be decrypted back to the original plain text. For hashing, the process is one-way and irreversible. So what are the applications of encryptions in the IT industry? We will discuss some popular applications such as HTTPS, storage encryption, and password management. Firstly, we will look at HTTPS. HTTPS stands for Hypertext Transfer Protocol Secure. The secure word means that web traffic is encrypted with a protocol called TLS, which means transfer layer security. So how does this works? Suppose we have a desktop communicating with a web server. When the user types the URL in the browser, a series of handshakes will take place to validate that the server is authentic. Once the server is verified, the client and the server will negotiate for the symmetric key used for the actual encryption of the data transmitted. However, the negotiation and sharing of the symmetric key are done by employing an asymmetric encryption, and this public/private keys are only specific for the particular browsing session. Now we move on to storage encryption. This can range from the encryption of a single file, to multiple files, to full disk encryption. A popular technology that is used on many Windows PC is called BitLocker. Similar to TLS, the actual content that the user wants to protect will be encrypted with a symmetric key. The secret is stored in the storage itself and can only be accessed based on an asymmetric encryption scheme. For example, BitLocker will check that the hardware has not been tampered together with some sort of input from the user before granting access to the secret. The last application that will be discussed is password storage. This is where a lot of even big companies like Adobe used to do very wrong. It is bad practices to store the user's password, even with encryption. Attackers can gain access to the systems, and when they do, they can get the encryption keys. How about hashing? It is also a bad idea. Attackers can generate a hash list once they know the hashing algorithm, and thus can compare the stored hashes with the hash list to extract the passwords. So what is the proper way to store passwords? The answer is the salted hash. What this means is that the user's password is combined with another randomly generated text, which is called a salt. The combined text is then hashed, and the hash plus the randomly generated salt are stored in the server database. Since the hash is random for every user, it is impossible for attackers to generate a hash table. Moving on, we will summarize the role of each encryption techniques in the overall security landscape. For symmetric encryption, it is suitable for encryption of large files, which favors faster encryption techniques. Some of the examples are storage and web traffic encryption, as discussed earlier. For asymmetric encryption, it is commonly used for the creation of digital signature or digital certificate. In addition, it is also used to encrypt and distribute secret of other symmetric encryption schemes. For hash functions, some of the most popular usages are checking message and file integrity, password verification, as well as data checksum, which is often used for detecting corruption. So what happens if security measures are not implemented, or a security measure is compromised? There are a lot of things, especially bad things, that could happen. For instance, in the banking industry, unauthorized transactions that were not initiated by the legitimate account owners could happen, which leads to monetary loss, damaged bank reputation, and distance potential investors. For individual users, their private data could be leaked and used for bad purposes such as extortion, identity theft, and so on. In the case of firms and businesses, proprietary products or strategic plans could be exposed to competitors, which causes the companies to lose their competitive advantage. Stakeholders like workers, investors, and consumers could be affected as a result. These are just some examples, and of course there is a lot more. Hope that you learned something new from this video and protect yourself against ever-increasing cyber threats. Goodbye.